Hello everyone. So here is our day 2 question. The topic I have chosen again is SHM and subtopic is physical pendulum. So this week I am planning to cover all good questions of SHM. So first see this question. So let's read this question and understand the question first. A thin bangle of mass m radius 2r is suspended on a smooth, horizontal and fixed cylindrical rod of radius capital R as shown. Means there is a bangle suspended on a cylindrical rod which is smooth, horizontal and fixed, and also the given position is equilibrium position. If you displace that bangle slightly in any direction, then it is going to perform oscillation and we need to find its time period. So that is the question. Question is looking very much straightforward and simple. So in the starting only I said the questions that I am going to bring here in this channel will be JEE advanced oriented question. So it's not like to impress you, I'll bring some Olympiad questions here, right? Here in this channel, all the questions will be JEE advanced oriented questions, right? Now pause this video and try this question. I'm 100% sure if sincerely you are trying this question, you will do mistake. Yes, the nature of physics is like this only, right? So we learn from our mistakes. So quickly do the mistake and then we'll understand, we'll learn from it. Okay. Now let me explain you the solution of it. First, the approach. What should be the approach? So the system is looking like a physical pendulum and our brainstorming angle should be towards finding torque about some axis, right? Some axis we'll try to find torque and we'll try to relate that torque with the angular displacement, right? So about some axis that is performing some rolling motion, right? So a feeling like this is coming by looking at this problem, that it is going to perform some kind of rolling motion, right? Now what is the crux point here in this problem? What we are going to learn here? So the crux point here is the bangle will not perform rolling motion, it will simply perform translatory motion. So that is the most important point of this problem, right? So it will perform translatory motion and I will explain you why. In rotational motion we have learned for any body to perform rolling motion there has to be some torque about its center of mass, right? About center of mass of a body. If there is no external torque, right, so then body cannot perform rolling motion. So same case is here also. Rod is smooth, it means bangle will not experience any kind of friction, means no tensile force on it. It means again no torque due to gravity. Gravitational force is passing through center of mass of the bangle only. Again no torque about its center of mass, right? So it means it will only perform translatory motion, right? And now the situation will be like this only. So this situation motion also I will show, but this situation, this problem and this thing that I'm showing, that are identical. Means any small point mass is there and it is oscillating on a concave spherical surface, right? So these two things will be identical. Okay, so now then how motion of bangle will look like? So see, that will be the motion. So if you are displacing it slightly towards right, so then topmost point of the bangle will rise up slightly, and you are releasing from here. Upon release, it will come down due to inertia. It will come down, will gain velocity. At the mean position, it is having some velocity. Because of that velocity, again it will rise up on the other side. So that is the other extreme position, and this motion is going to repeat. So it is just like center of mass of the bangle is performing this motion. So center of mass is performing oscillatory motion about point O. So it will be just like this. So now what we need, it means we need to express torque acting on the bangle about point O. So about point O, how much torque is acting on the bangle, that we need to find out, right? So again, normal action will not give any torque about point O. The only reason for torque is gravitation force of the bangle. So gravitation force of the bangle for any small angular displacement theta will be mgr sine theta. So that we can write is equal to I alpha, where I is moment of inertia of bangle about point O. So about point O is a moment of inertia, we can write. And then alpha is equal to this quantity, omega square is mgr by I, right? So time period of its oscillation will be 2 pi under root I upon mgr. So here I will be mr square. So again here is a mistake alert, right? Mistake alert means it's not like what I have written here, that is a mistake. No, generally students do mistake here. So what students feel, that about point O we are writing moment of inertia, about center of mass of the bangle moment of inertia is mr square or m into 2r whole square. Then again we have to apply parallel axis theorem to write moment of inertia point O. So that will be wrong, beta. Why? Because it is not having any spinning motion. So about point O, if I am applying parallel axis theorem, since it is not having any spinning motion, moment of inertia about its center of mass will be considered as 0, right? Because it is not rolling motion, it is just a pure translatory motion. So that is a very important point here, right? So moment of inertia will be just like this. I is equal to moment of inertia about center of mass plus m into d square. So here IC is what, beta? 0, no spinning motion, and then plus md square, d will be equal to r. So moment of inertia about point O means the center of the rod will be mr square. So substituting the value, we will get time period as 2 pi under root r by g, right? So that is the right answer. So if students have not done mistake, then good only, no problem in that, right? So, and the students who have done mistake, please see where you have done mistake and try to rectify it, okay? So you are doing this problem by any other approach, then in the comment section you can tell that what approach you are using, and then I will pinpoint your mistake, right? Thank you.